SDGs Challenge 2024. Navigating the Future, AI-powered maps for the visually impaired. Good morning, good afternoon, or good night. I'm presenting a solution that aligns with SDG 10, Reduce Inequalities. Our project focuses on tackling mobility challenges faced by visually impaired individuals. Those with visual impairments rely on auditory cues such as sounds of traffic or the echoes in the environment to understand their surroundings. However, in silent streets, parks, or in isolated areas, these crucial auditory indicators are absent, making it nearly impossible to move independently. This creates mobility barriers. Our solution is to develop a wearable AI-powered navigation system that addresses this gap. This system uses technologies like sensors, cameras, and AI algorithms to provide real-time step-by-step navigation assistance. The wearable device features small cameras, ultrasonic sensors, LiDAR, light detection and ranging, and infrared sensors that can scan the user's surroundings continuously. These sensors collect environmental data, detecting obstacles, objects, and landmarks. The data is then processed by an onboard AI system which creates a 3D map of the surrounding and identifies key features like stairs, curbs, or crosswalks. Once the AI processes this information, it translates it into clear, actionable voice instructions, which are delivered through a speaker or a bone conduction headset, depending on the user's preference. The system provides instructions like obstacles ahead, move right. This allows visually impaired users to navigate unfamiliar spaces with ease without the need for auditory cues from the environment. Moreover, the device offers dynamic updates based on the user's pace and any real-time changes in the environment. For example, if there is a sudden construction on the path or a cloud forming on the sidewalk, the system can immediately adjust the route to ensure continuous safety. This flexibility ensures the system can guide users efficiently in both predictable and unpredictable surrounding environments. To enhance inclusivity, the device will also feature a community support function. This feature connects users with nearby volunteers who can offer assistance if needed. When a user's device detects a nearby volunteer, it notifies both the user and the volunteer, fostering a support network while maintaining the user's independence. The primary goal of the initiative is to reduce inequality and empower visually impaired individuals to move freely and safely in urban spaces by offering real-time guidance and facilitating community connections. This solution helps create a more inclusive and accessible society. We will start by creating a basic prototype using open source platforms like Raspberry Pi and Arduino. These platforms are available with the flexibility to integrate sensors and cameras that are necessary for the device. The initial steps will be focused on basic environmental sensing, using ultrasonic sensors to detect obstacles and cameras to recognize objects. We will work with open source AI platforms like Tencent or OpenCV to begin processing into actionable information. Once the basic prototype is functional, we will test it in controlled environment to refine the system and see how it performs. We will gather feedbacks, making sure that the device works well for them, adjusting the system based on their input. The next phase will involve developing a mobile app that can link users with nearby volunteers. This app will be having a easy-to-use interface where volunteers can sign up to be available for assistance. The app will notify the volunteer when their help is needed and give them the user's location, fostering a sense of community support. As the prototype becomes more and more refined, we plan to partner with local organizations and work with visually impaired individuals to further test the system, like city streets and public spaces. These partnerships will provide valuable insights into how the system works in urban spaces and what adjustment we need to make. Finally, we'll focus on scalability. By designing the device to be adaptable and compatible with various cities, we can expand this solution beyond our local areas. Additionally, a multilingual interface will ensure accessibility for the user from diverse linguistic backgrounds, making it a truly global solution. This approach will also allow the system to be adapted to different urban spaces, ensuring it works in various geographic contexts. Through phased approach, we can gradually build a more robust and efficient system while keeping the focus on real-world usability and feedbacks from those who will benefit the most. To summarize, this project directly addresses the mobility challenges of visually impaired individuals, creating a solution that fosters independence, inclusivity, and community. By reducing inequality and enhancing urban mobility, we are contributing to SDG 10. Thank you.